Welcome everyone to Pakistan Dreamin 2021 sessions. My name is Vernon Keenan. I'm from Salesforce Devops.net and I am a senior industry analyst working out of Oakland, California. I've been in the industry a while, it's true. I started out when I earned a biomedical engineering degree at Northwestern University, where I programmed a PDP-8 with punch tape and measured insulin in rats. Very rounded. In my long career, I've been a teacher, SPSS programmer, database administrator, clinical researcher, technology journalist, product marketing manager, market researcher, management consultant, and industry analyst. I actually got started with Salesforce right at the very beginning when my ex-boss from Oracle, Mark Benioff, gave me my first login in 1999. Most recently, I'm a telecom operator, Go architect, Go engineer, and Salesforce developer architect. Today's topic is build better apps with Salesforce Devops. Let me tell you a little bit about how I came to see DevOps as the key to unlocking Salesforce as an app delivery platform. Until very recently, Salesforce suffered from being in a developer backwater. I could go through all the litany of woes I had in the 2010s about Salesforce development, but it all boiled down to speed. Using tools like change sets, Eclipse, and Developer Console, I found it extremely frustrating to do things like copy metadata between orgs. Salesforce development was, and pretty much still is, very slow for developers. This was pointed out to me in the extreme when I recently crossed over to the cloud-native world and basically ported much of an existing Salesforce org over to microservices. I used the strangler pattern to make a bunch of microservices in Go, and I was blown away and embarrassed by how much more advanced software engineering techniques are in Go and Kubernetes when compared to Salesforce. Obviously, there's a fundamental difference, and you really can't compare the two, but I knew that Salesforce was getting left behind. Then we have a global pandemic, and the demand for digital projects skyrockets, and all of a sudden the speed with which one builds a Salesforce app becomes a big deal. That's when I noticed a unicorn job description popping up all over the place. Technical architect with DevOps engineering experience. That led me to find the top 5 Salesforce DevOps platform companies who are essentially trying to productize that job description. So I noticed there were no writers or other analysts in the space, and so in April 2021, I started Salesforce Devops.net as a website for the global community. Includes every one of you people out there who I love, and I'm doing it for you. So let's get started with today's session. Let's commit. I spent 2021 curating and cataloging the companies, products, and services that help Salesforce customers deliver enterprise applications. Here is what I've learned, and I am ready to share. It is my goal to give you a general view of what DevOps is. Then we will get more specific and try to define Salesforce DevOps. Next, we will get into some of the build versus buy issues and learn a bit about building your own DevOps pipeline from scratch. Then I will take you through the top 5 Salesforce DevOps platforms, and I will give you my quick take on each of them. Finally, we will try to elevate ourselves to seeing the next thing in DevOps, App DevOps. If you are doing DevOps today, that says you are managing how to build the means of production for your organization. If you want to exist as an enterprise in the digital domain, then you need DevOps to have the automation capabilities that delivers enterprise app updates and continuously improves app value. The origin of the DevOps concept started in 2007 when its main push was to find ways to obliterate barriers between app developers and system operators. Developers became frustrated with the time it took to iterate on software builds when dealing with operations teams. This diagram from Azure DevOps portrays it beautifully. It shows how better communication results in the collaboration and teamwork necessary to manage, develop, deliver, and operate a live application. It shows the main benefit of using DevOps, which is to have a mechanism that allows teams to respond quickly to user behavior. Another key to the success of DevOps is the idea of metrics and observability and how that dovetails with agile management philosophies, such as tying metrics into objectives and key results. In fact, I'd say that DevOps and Agile have been kissing behind the barn, and a new unified app production perspective is evolving, which I call DevOps 3.0. To talk about how DevOps has changed over the years, I've divided its history into 3 separate eras. I call this the DevOps 1.0 to 3.0 evolution. As I mentioned, DevOps was conceived in early 2007, and in those early days, the need to break communication and cultural barriers were the main subject of discussion. Then, in the last decade, we have steadily seen a progression where those barriers have come down, and many organizations are now on a road to faster development cycles and a better ability to respond to user behavior. Let us take a little tour of these DevOps eras to see where Salesforce fits into the picture. DevOps 1.0 grew in power as cloud computing made it easier for a developer to spin up new IT infrastructure. In the early 2010s, Docker accelerated DevOps 1.0 by creating deployment artifacts that behave like little self-contained virtual machines. Today, Docker containers are the main artifact type generated by 1.0 cloud-native build automation processes. Jenkins then emerged as the first free open source implementation of a DevOps 1.0 command server. This happened in 2010 and 2012. Jenkins uses webhooks and scripting agents that automatically compile and link source code into an artifact. Artifacts are then continuously delivered to a production environment. Jenkins is still a leading pipeline orchestration system and command server in 2021. Jenkins-driven continuous delivery accelerated development, which enabled technology companies to update their cloud-native apps faster. Companies delivered small changes to an app continuously. This allowed them to see how audiences reacted to small changes in an app. This allowed the technology companies to use continuous delivery to learn more about the psychology of their users. DevOps 1.0 emerged as a transformational force in the technology industry. Guided by its old motto of "go fast and break things," Facebook used continuous delivery to fine-tune their products. Facebook and other app developers grew their markets by learning how to addict users to their app. They used continuous integration to experiment with small incremental changes to amplify user behavior. DevOps 1.0, as practiced by technology companies, evolved into a new set of job functions that I call DevOps 2.0. This was done as the need for online system integration services spread globally throughout the 2010s. After seeing how Silicon Valley used DevOps 1.0 to dominate the internet with innovative apps, big organizations around the world started using the same tools. DevOps 2.0 blossomed when corporate IT teams started using the software used by Netflix, Uber, Airbnb, and Twitter. Eventually, many organizations began to effectively copy how Silicon Valley delivered cloud-native applications. This increased interest in cloud-native computing, and DevOps 2.0 ignited an explosion of open-source projects. This created new communities and companies to support pivotal projects like Jenkins, Apache Kafka, and Kubernetes. By the mid-2010s, enterprises had access to many of the cloud-native goodies that Silicon Valley still uses to build and deliver technology products. The pandemic has inspired quick adoption of new management practices. Many of these are centered around the Japanese Kanban board and process flow management practices. The shortcut term, Agile Management, now describes this management philosophy. In the last decade, Agile Management has demolished some traditional corporate structures because Agile doesn't respect traditional hierarchical communication. Agile organizations create ad hoc and permanent teams to deliver on objectives and key results, otherwise known as OKRs. This methodology finds its roots in the management by objective techniques that started in Japanese manufacturing in the 1960s. Based on scientific methodologies, OKR-driven management seeks to create measurable outputs in the processes that achieves a key objective, which is also measurable. For example, a Salesforce app could have an OKR like deliver a field service app that improves service rep response times by 30%. Just like how the term DevOps is now an overly generic way to refer to enterprise application delivery, the term Agile has evolved to represent the management techniques inspired by the Kanban board and other OKR-related topics. The general topic of DevOps and Agile is becoming somewhat blended as well. DevOps and Agile share the philosophies of continuous delivery and user testing, enhanced communication, and advanced project management tools. Now that we've thoroughly discussed DevOps and the cloud-native world that it helped to grow, let us see how it relates to Salesforce DevOps. One reason why Salesforce DevOps has gained prominence is because it represents the convergence of three huge business forces. First, Salesforce is now a business transformation platform and not just the CRM. Since the platform is strategic for many more businesses, executives need a governance harness and better visibility into digital app production activities. Next, we have the cloud-native world of traditional DevOps, which we have been discussing as part of the convergence. And then in 2017, Salesforce became accessible to the cloud-native world. That is when SFDX CLI was introduced, and that really made Salesforce DevOps take off. It allowed Linux scripts and cloud-native tools to now interact with the configuration information inside of Salesforce. That subsequently allowed cloud-native automation tools like Jenkins and Azure DevOps to act as a command server in a release pipeline orchestration scheme. I made this relationship classification system to help figure out if all the boxes are being checked when you are building a continuous app delivery system. This diagram gives you an idea of the complexity involved in a Salesforce DevOps solution. So the good news is that we have good roadmaps for how to build a DevOps solution, but the bad news is there are still a lot of things to do and a lot of systems that need to be tied together. That is where one of the top 5 vendors come into play. Salesforce DevOps platform vendors are all working to check off these boxes for you, so they are worth a look if you are getting started. Now let us take that mess of products and reorganize them into this stack. This summary shows how Salesforce DevOps is first controlled by the governance functions, which collects metrics and data from the app production teams. Next, these teams of architects, developers, admins, business analysts, and the constituents use a consistent set of automation and deployment tools to continuously optimize apps. One thing that makes this different for Salesforce apps is the curious way in which we must manage metadata. A key function in Salesforce DevOps is that metadata must be ingested, analyzed, queried, and dynamically updated. When updating a live org, this is the only way for an app production team to work together. There must be intelligent metadata management in any Salesforce DevOps platform to optimize your release management processes. Now we are expanding the pyramid to show a system architecture diagram for a full-fledged Salesforce DevOps solution, pretty much like what you would get with one of the top 5 solutions we will discuss soon. Here we can see some of the more familiar names and details that go into creating a full DevOps solution. The elements are stacked in order of functional granularity and generally are related to adjacent layers. I call it an industry map because if you go to salesforcedevops.net and go to the map section, you can basically click into any of these categories and see the companies that I've curated. Now, here is another view of the Salesforce DevOps industry. Ben McCarthy of Salesforce Ben and I worked together to design this periodic table of DevOps solutions using the salesforcedevops.net database. This will be published September 27th on his site, so you are getting a world premiere preview of this new infographic. You can see all the categories I laid out in the ontology and map illustrations. If a company has a product in a category, it gets a badge. For example, you can see the G symbol for gear set showing up in multiple categories since they are a leading Salesforce DevOps platform. I know this is an interesting graphic, so I'll go through all the categories and you can get a chance to check it out. Repository management. These companies have Salesforce-specific source code management solutions. Release management. The complex process of using repositories to deploy new releases to your Salesforce org is supported by these companies. Cybersecurity. These companies help you integrate key application security features directly into your development pipeline. Data backup and recovery. These companies help you back up your org's data and to integrate backup processes directly into your DevOps pipelines. Profile management. These companies offer another key utility in DevOps pipelines, the ability to copy and manage profiles. Data transformation. These companies offer export, translate, and load, or ETL tooling, and the ability to integrate data ingest and export into your DevOps pipelines. Testing tools. Testing is a multi-layered concern, and these companies help you use modern methods to increase app delivery reliability. Sandbox management. These companies offer advanced Salesforce sandbox management features, including data masking and managing privacy concerns. Observability. These companies support the use of metrics, incident management, and graphical analysis for application performance management. Pipeline orchestration. These companies offer a command server which runs on Salesforce or a cloud-native application, and that manages the execution of processes that perform release management and other DevOps functions, also known as a CI/CD tool. Engineering services. These are companies who, in addition to offering software services, have professional services practices for DevOps system development. Application management lifecycle. These are companies who make the tools used to manage software teams. Value stream management. These companies have advanced agile management tools we will discuss more later. So, be sure to watch out for that article, which will come out the week after Dreamforce, and go to salesforcedevops.net right now to find these products and companies. Here is another fun slide. This portrays what goes into a DIY or a platform-based DevOps solution. Most Salesforce DevOps activity centers around what I call a command server, which is also referred to as the CI/CD engine. The command server is a program that manages the system activities during Salesforce release management. Using a command server to automate the release management cycle is a real benefit that decreases Salesforce deployment times. The Salesforce DevOps command server runs either on Salesforce, on-premises, or as a cloud-native application. For example, both Capado and Flowsum run their platform on top of Salesforce, while AutoRabbit, Blue Canvas, and GearSet all have their own cloud-native apps, which is called the public DevOps cloud in this diagram. The top 5 platforms also allow for integration of private command servers into how the platforms manage Salesforce releases. In this diagram, I show how some Salesforce architects create their own command server by running it on private enterprise resources. This is where the enterprise often uses Azure DevOps or Jenkins to set up a private DevOps command server. Each enterprise IT environment is unique, and this illustration shows all the enterprise DevOps resources deployed on-prem. Other implementations may spread those services around to Salesforce, public clouds, and other DevOps clouds. So let's drill into the main parts of this diagram. Now, let us continue being practical and talk about some of the ways to set up a DevOps workflow for developers. First, allow me to say that it is essential that developers be working in SFDX, CLI, and VS Code on a daily basis. The days of Developer Console and Eclipse are over. If you have not yet figured out how to get going with VS Code, that should be job number 1 in your DevOps journey. One major problem in enterprise app delivery is setting up the individual workstations to support Salesforce VS Code integration. I have a favorite technique to get around this issue by focusing my setup efforts on a Linux server. As I show in this diagram, it is deployed to the same network in which I have my workstation. I then use VS Code Remote SSH to use my Windows or Mac workstation as kind of a terminal client. This setup, plus GitHub configuration sync, allows developers to get up and going on a brand new workstation in a fraction of the time compared to manual setup. I mentioned command line interfaces, or CLIs, because these are super important. CLIs provide a connection between cloud systems like Salesforce and Linux scripting. Now, when I talk about Linux scripting, I specifically mean Bash scripting on either the Red Hat, Debian, or Alpine Linux platforms. It is important to have a standard scripting execution engine when developing your own Salesforce DevOps scripts. I already mentioned SFDX CLI, and it is fundamental in Salesforce DevOps for a couple of reasons. It not only provides a way to read and write metadata to a live Salesforce org, but it is also a platform from which independent software vendors may deploy other developer-related tooling, For example, DigitSec S4, which is a suite of cybersecurity solutions, performs an application security scan using an SFDX CLI extension. There are literally hundreds of CLIs you could include in your Salesforce DevOps scripts. My favorite open source packages are DX at Scale, which comes from Accenture in Melbourne, Australia, and Cumulus CI, which comes from salesforce.org. Each of these packages have a CLI or a whole set of CLIs that you use to manage deployments. Let us talk more about what I call the DevOps command server. I like to use that wording because I find the term CI/CD server or tool to be off-putting and intimidating. I like command server just because it is more understandable. This is where we get into the build versus buy issues. Here I am illustrating 3 of the most popular ways to automate Salesforce DevOps pipelines if you have more of a build mindset. The name Azure DevOps is slightly misleading because you don't even need an Azure cloud account to run Azure DevOps. In fact, Azure DevOps is a Windows server that comes on an ISO. And most sites with Microsoft licensing agreements already have access to this ISO for free. Plus, the software is usable and should be familiar to most users with IT admin experience. Jenkins has the distinction of being the oldest DevOps command server, so it has the biggest user base. CloudBees, which is a massive DevOps services company based on Jenkins, supports Salesforce. That means there are some big Salesforce DevOps projects out there using Jenkins. Finally, GitHub Actions is the latest kid on the block, and it is easy to use. So there is widespread adoption, and it is easy to get started, and we are seeing it used in Salesforce DevOps projects. If you're a big company, then you may want to figure out how to deploy centralized IT resources to your developers. This way, they don't have to use cloud services for everything. The result can be much cheaper and more secure, and it lets you experiment with scripting resources and some of the other techniques I've mentioned. I wanted to touch on those cloud services on the right-hand side of my system integration diagram. By Salesforce platform, I am referring to all of the different cloud services in the Salesforce family. Public clouds refers to other SaaS platforms such as AWS, GCP, or Microsoft Azure. It could also be another cloud service provider besides Salesforce, like ServiceNow. Or it could be SAP versions of online versions of SAP or Oracle. I'll talk more about app DevOps in a bit. And the public DevOps clouds are providers like GitHub, CloudBees, AutoRabbit, GearSet, or Blue Canvas. These companies have public cloud native apps which interact with your Salesforce org on a cloud-to-cloud basis. Remember how Agile and DevOps were kissing behind the barn? Well, that is a reference to how DevOps and Agile management really depend on one another, and in fact, DevOps can be seen as the engine of an Agile management philosophy. And this whole thing is now expressed as a Scaled Agile Framework, or SAFE, which is a set of organizational and workflow patterns for implementing Agile practices at an enterprise scale. To help this process along, More Japanese management techniques related to Kanban have emerged. These techniques are called value stream mapping and value stream management. Focusing on process analysis, value stream mapping starts at the app production team level. It assesses the way elements within a complex project interact to achieve an operational objective. Value stream mapping process generates a graphical product called the value stream map. Planners create maps that describe the current and desired value streams. By doing so, provides a guide for process improvement. Also, these diagrams kind of seem a little strange. So it's because they were originated from the Toyota factory floor. So don't let that get in the way of using them. Value stream management is the DevOps automation harness, or the tools and practices that measure the ongoing dynamics of individual value streams. To become more widespread, value stream mapping and management tools need to be integrated directly into a DevOps 3.0 platform. With the automation tools available to developers today, there is much to be gained by focusing on developing automation techniques before getting busy with code. I cannot overemphasize this point. You might spend days or weeks dreaming about how you would automate this or that. The thing is, if you don't have a way to kick off some sort of automated process based on a code commit or other developer action, you are wasting too much developer time. If you cannot deploy a change set via a script running on a command server today, then you are wasting a team member's time by making them log on and do the same task. Remember how I mentioned how SFDX CLI gives us a touch point between the Linux scripting world and the Salesforce cloud? Well, another huge way to take advantage of cloud-native computing and all of its goodies is to use a Git-compatible source code repository. So you really need to get your code up on GitHub or another cloud-based repository. If you don't want to go to the cloud, I recommend using an open source project called Gitea to host it privately. Okay, let us go into a description of the top 5 vendor-based Salesforce DevOps solutions. When looking at these solutions, here are the essential features you want to compare. Some of the packages use Git behind the scenes automatically, while others require that you manage the repo yourself. The next big thing to consider is how will this package fit into your release workflow, and can it be used to help optimize workflow in your app production teams? All of the packages have different approaches to specifying how to move code through a release process. Remember, you don't necessarily have to replicate your current release management scheme. Some vendors might be able to help you optimize it. Finally, a key competitive differentiator in the space is what does a service provider do with all that metadata that gets continuously ingested. Some of the service providers do important things like perform a census of metadata usage, create dependency maps, keep teams from overwriting metadata, and anticipate errors before deployment. Most of the top 5 vendors also offer integrated versions of these features which we have discussed. Sometimes a vendor like Blue Canvas doesn't support these features but has an open platform that encourages you to integrate other vendor solutions using CLIs and scripts. I do not have a comparison matrix for these companies quite yet. Maybe next year. I do have some basic characterizations I can share with you though. AutoRabbit has a cloud-native server that ingests metadata and helps to intelligently manage the release process. They are focused on the financial services sector and support several AppExchange packages, like Encino. Blue Canvas, like I mentioned, doesn't really address the top part of the Salesforce Devops.net industry map, like the other 4 companies in the roundup. They have a cloud-native architecture that uses the Go programming language and translates into better speed and flexibility using their cloud-native app to ingest Salesforce metadata. The Blue Canvas app also runs a command server and manages branch-based development. Blue Canvas does not seem to need as much upfront consulting assistance compared to the others and can achieve a faster return on investment. Capado is by far the market leader in the Salesforce DevOps platform space. They have the biggest global footprint with a strong presence in Europe. Their architecture is to put everything onto Salesforce, so Capado is mainly a Salesforce-based application. They recently got a Series C investment that put them over a $1 billion valuation. Capado is acquiring companies like crazy. They also seem to have some of the biggest Salesforce accounts in their corner. They just put out a nice series of bite-sized videos on YouTube, so go check that out if you're interested. Maybe it is just because they are so big, but I've heard complaints about Capado's price, complexity, and speed. Since they are getting so much big enterprise business right now, I'd be cautious using them for smaller projects. Flowsome is another Salesforce platform-based solution like Capado. They have a strong USA presence. They compete pretty much head-to-head with Capado, and I believe that Flowsome addresses some of the complaints I just mentioned about Capado. GearSet is one of my favorites because they do so much to educate the industry and teach about DevOps. Their founder, Kevin Boyle, is a real leader in the industry. On the downside, I believe most of their support resources are in Cambridge, England, so that can present some issues for US-based users. You can go to the GearSet website and get a whole bunch of basic information on Salesforce DevOps, so thumbs up for that. GearSet also has a cloud-native architecture like AutoRabbit and Blue Canvas. I've heard about a fair number of consultants who now use GearSet for org discovery and documentation, and that GearSet may be better for smaller projects. As systems become more intertwined, a need for a holistic view, which I call App DevOps, is emerging. This seems like a natural evolution as the need for multi-cloud orchestration increases. Some Salesforce-compatible orchestration and command servers already offer limited multi-cloud capabilities. Let us go through this architecture diagram, starting from the bottom and going on up to the top. The bottom layer is hyper-converged infrastructure, which represents the compute, storage, software, networking, and telecommunications resources required to build a giant cloud service like AWS. The cloud service providers then resell those services by offering APIs to provision and use the hyper-converged architecture. Application service providers then use the cloud service provider APIs to provision and operate cloud-native applications running in the cloud. Next is the cloud-native DevOps layer, which delivers cloud-native apps to be run by application service providers. Remember the DevOps eras from earlier? This is where the DevOps 2.0 engineers assemble scripts, run command servers, create online repositories, and use other resources that take source code artifacts and then create runtime artifacts. Those artifacts are then deployed in a cloud-native application that uses cloud service provider APIs. The next layer represents the cloud-native apps themselves. In this diagram, it shows Salesforce and other applications. These are the cloud-native applications. These applications offer programmatic and low-code application development capabilities that create enterprise apps. The other applications could be big enterprise packages like SAP or Microsoft Dynamics 365. Sometimes these other applications are customer data platforms, which help to round out a Salesforce 360 strategy. The next layer, App DevOps, is the technical and human interface between SaaS service providers and the digital objectives of the company, which is pretty much how we've been discussing Salesforce DevOps. So, ideally, App DevOps will give us ways to intelligently manage the flow of information and metadata between multiple high-level cloud-native applications. After all, do you think we're going to have SAP DevOps, Dynamics DevOps, and Salesforce DevOps forever? Eventually, there will be a convergence. To round out today's presentation for PAC Dreamin 2021, I'm going to share with you my demo for my favorite Salesforce utility, SFDX CLI. I'm going to show you how I install it on Ubuntu, and this is going to be extracted from a blog posting on my website where you can find the links referenced in the video. Check the accompanying blog posting to the link to the full set of instructions for completing this tutorial. You can follow along by copying and pasting the scripting code from this GitHub gist on my account. I'm going to take you through the way that I like to install the CLI for myself that includes some productivity tools such as the ZSH shell and Oh My ZSH enhancement, the node version manager, and finally the CLI itself. And that's all done to support the autocomplete feature in the CLI so that we can easily access the hundreds of different options available in the Salesforce CLI. Oh My ZSH uses a Powerline font to do its coolest features. So step one is to download and install the TTF font file that I linked in the blog posting. I've successfully installed and used Code Retina as a Powerline font on Mac, Linux, and Windows. So that's a step that I leave up to you. For the demo, I have a server called Devops that is set up with my username Vern, and it is a fresh Ubuntu installation running Bash shell. To get started, we are going to install the ZSH shell as root, and let us paste in an apt install command, and then the change shell command to set ZSH as default. Then we're going to log off the workstation, log back in, and I'm going to hit 2 here to set it up to set up ZSH with the default scripting environment. Next, to install Oh My ZSH as a user, we start off by pasting in the simple shell execution command. And to configure Oh My ZSH, I'm going to paste in some more. I'm going to log off first, and I'm going to log back in. Then I'm going to paste in some of these sed commands to configure Oh My ZSH with the recommended style and plugin. And then this git command is going to install the autocomplete database. Node version manager is what makes this procedure simple. So we paste in that shell command. And then I'm going to refresh ZSH and then use nvm install --lts to install node. And then I'm going to install sfdx CLI with npm install -g space sfdx CLI. That takes from 1 to 5 minutes, depending on your workstation, for npm to complete. And then to test the installation, I'm going to type sfdx, and I should get back this display that shows it's working properly. To show off autocomplete, let us zero in on the auth command. First, I will do a full listing of all the commands available by typing sfdx tab. Then I will add a tab to see all the authentication commands. Then I will pick the device authentication option and hitting -tab to see the command options. I'm going to set my default DevHub username. I'm going to do an authentication action off screen, and I'm logged in. In summary, I hope I've shown you how building up expertise in Salesforce DevOps will help you get things done faster and more efficiently. As you go forward, you will first be confronted with that build versus buy decision. If you haven't had the chance, try to find out teams who are starting out on new projects and get them to use build automation from the very beginning. But if you don't have cloud native experience, then using Salesforce specific DevOps products from one of the top 5 vendors may be a safer choice. So I'd like to thank the sponsors for producing Pack Dreamin 2021, and I'll see you next time. But first, I think we have questions.